Have you ever wondered how the human body, a marvel of engineering, carefully balances dozens of interrelated chemical and physiological parameters to sustain life? This intricate balance, a testament to the complexity of our bodies, is something that writer Steve Lofman has explored extensively in his thought-provoking articles. In his writings, Lofman delves into 40 interrelated chemical and physiological parameters that the human body must carefully balance to sustain life. He introduces the concept of functional coherence, a principle that highlights how interdependent all these elements are. Everything in our body is so tightly integrated that a change in one component requires corresponding adjustments across the system. This interconnectivity, coupled with the sheer scale of our body's operations, makes change a challenging endeavor. Lofman argues that this complexity and coherence of our bodies stand in contrast with the Darwinian notion of gradualism. This perspective posits that significant changes occur over time through small, gradual modifications, which seems to contradict the intricate, interdependent nature of our bodies. So let's dive deeper into this concept of functional coherence and how it impacts the human body's ability to function. Functional coherence in the human body implies that a significant change in one component usually requires corresponding changes in other components. This concept is a cornerstone of the fascinating work of Steve Lofman. In his article, "The Design Body Continued Coherence Wins, Gradualism Fails," Lofman paints a vivid picture of the human body as a complex, interdependent, and beautifully engineered system. He describes how the human body exhibits functional coherence on a scale that is so far beyond our experience as human engineers that we have no comparable systems to compare it to. But what does this mean, exactly? Well, it's like a finely tuned orchestra where every instrument must play in harmony to produce a beautiful symphony. If one instrument changes its tune, the entire symphony is affected. In a similar vein, the human body is a coherent system of at least 40 interrelated chemical and physiological parameters that the human body must carefully balance to sustain life. A significant change in one component or subsystem typically necessitates corresponding alterations in other components or subsystems to maintain the overall function of the whole. If you think about it, it's a bit like a domino effect. This brings us to the concept of Darwinian gradualism. This theory suggests that biological entities evolve over time through small incremental changes. However, the principle of functional coherence challenges this notion. Let's take the example of an internal combustion engine. If an engineer changes the length of the piston rods but doesn't adjust the crankshaft accordingly, the engine won't start. Just like this, processes of development in biological systems are so tightly integrated that one change early in development will demand a multitude of other coordinated changes in separate but functionally interrelated processes downstream. So you see, the concept of gradualism faces a significant hurdle when it comes to functional coherence. It's not simply about one change at a time. It's about a cascade of changes that need to be perfectly orchestrated to maintain functionality. But this complexity doesn't stop at the macro level. It extends all the way down to our DNA. Even at a genetic level, our DNA showcases a level of polyfunctional complexity that seems to defy the principles of Darwinian gradualism. In a 2013 article titled "Multiple Overlapping Genetic Codes Profoundly Reduce the Probability of Beneficial Mutation," the complexity of DNA was brought to light. This piece highlighted that beneficial mutations, the driving force behind evolutionary changes, are incredibly rare when compared to deleterious or harmful mutations. This rarity becomes even more profound when we consider overlapping genetic codes. Every single nucleotide in our DNA can contribute to at least 12 different genetic codes. This means that a single base pair in our DNA can be a part of multiple codes at once. Now try to imagine the impact of a mutation in such a scenario. If a mutation occurs, it doesn't just affect one genetic code, but potentially several. This drastically reduces the chances of a mutation being beneficial. As the number of overlapping codes increases, the probability of a beneficial mutation decreases exponentially, almost reaching zero. This mathematical reality seems intuitively obvious, yet it profoundly changes our understanding of how beneficial mutations occur and how frequently they might contribute to evolution. Dr. John Sanford, a renowned geneticist, has expressed this conundrum eloquently. He stated, "It's becoming extremely problematic to explain how the genome could arise, and how these multiple levels of overlapping information could arise, since our best computer programmers can't even conceive of overlapping codes. The genome dwarfs all of the computer information technology that man has developed." The human body, in all its complexity, continues to astound us, challenging our understanding of life and evolution, and reminding us of the intricate engineering that sustains us every moment.